All right, more slope and bearing. On this one, we're going to have a little fun. So we're actually going to deal with some things more like a practical application here. And we're doing a little topography, so we're having a little introduction to that. And what we're going to do is, first thing, you're working for a petroleum company and you need to drill a new tunnel. And the pipe needs to be able to lay through this tunnel. And it needs to go through points 1 and 2 and then 2 to 3. Line 1 to 2, the bottom of the tunnel has 11 degree slope. So it has 11 degree slope coming up from 1 to 2. So we're going to have to find where 1 is and have that 11 degree slope. The tunnel then levels off from 2 to 3, so that means it comes straight out. And then we're going to pretend like we've cut through this. So we're going to pretend like this line right here is our cutting line, and we've cut the mountain in half. And we're looking through the mountain to see where we've drilled the hole. And then after you do that, you would find your length in the compass bearing and all that. So let's start off having a little fun here. Step 1, find you horizontal line to use as your straight edge reference point, and tape this puppy down. I actually need to move this up a little bit. Make sure it's nice and straight. Got a triangle. And match everything up. So let's start here with the number 1. I'm going to bring 1 down. Bring 2 straight down. Bring 3 straight down. Trying to see if I can get that in here a little bit better. Okay, there. You can kind of see it better now. There it goes. So I brought the points straight down. Next, what I need to do is I need to go ahead and mark your thing and find the actual point. So I know 1 hits, and if I look at the little topographical line, hits on the 20. So that's the 20 here, because this is 40. So there's like our elevation showing us here. So the 1's going to hit here on the 20. So I know from here it needs to have a slope that goes of 11 degrees. So we need a slope coming up of 11 degrees. Protractor, line it up. Here's 10, 11. Mark it. All I did was mark it with a point. Connect those. So what happens is this is where 2 hits right here. And then 2 comes over straight horizontal. So I'm going to get my darker lead. Actually, let's just do it light for right now because we need to go ahead and project those points, and so you can see where the mountain and stuff comes. And then we'll go back and darken. So here's 1 to 2, 2 to 3. Now, let's line these points up and bring it down. Okay, so let's start with a point here. So this point here hits on a 40. So it's telling us topography, it's a 40. Bring that down to where it hits the 40. And there's a point. Getting lighter. Okay, the next one hits this line that's going through here, our cutting plane line essentially. And it's on a 60. To 60. Point. This one's on the 80. Point. 100. 120. 120. Follow it around 100. 80. 60. And that hits right on the 40. ready? I know this sounds weird, but you just sketch it, the profile. And if I was doing this with a real map, I would actually have even more points in here that I could note the dimensions they match. This is just a simplified version. So I know, because I've drawn that profile, that that's actually where it's going to kind of end for the 3. So it's going to come out to there. Come on. Darken that in. And then you represent, see, I'm just running it parallel because we're not going to try to hatch the whole thing. And I'm not going to hatch the whole thing. You can go back and hatch it too. So that we know that that's what we're dealing with Earth, and we know that it hits here and here. Okay, now one of the things that asks you for down here is to find the length. So let's actually measure it. And just write it down and record what we have here. So I see the distance from here is 1.5, 6, 7. So from there to there, 3 and 1 to 2 to 3 is 1.7. And 1 to 2 is 2.4. And this is what you're going to do your scale, because the scale right here tells you that 1 is equal to 60. Okay? So I know automatically that, okay, so that's going to be 120 plus the 0.4. So a little math, each one of those is 6, right? So it's 120, 6, 12, 18, 24. So the length of that one should be 144, right? And then you would find the same by doing the math over here, and you would find what's the length here. Again, using it at the equals 60. And then you need to find your compass bearing. So looking at my compass bearing, which direction is it moving? And this time we have to find our actual north, because you can't just assume that the north is actually plain old straight up and down the north. So we're going to have to move our straight edge down a little bit so we can draw a little visual to figure it out. I'll line my straight edge up with the north. Dang it. That's why you tape it down. Line it up with a straight edge. Tape it so it doesn't move. So this direction is north. This is north, this is south. And your east and your west. On my 3. Draw my north and south. East, west. Okay. So I found all of my north and my south and my east and my west. I've drawn them. So let's mark it here just so we know that this is north, south, east, west. So knowing that, which direction is 1 to 2 going? So I look at it and I notice that it's coming down to the right, so I know it's going to be southeast. And then I need to find my angle. How do I do that? Can you think back to the previous one that we did? So we used our compass again, so we did all here. We know that this is our angle we're working with. So let's find what distance is the angle going. Lining it back up with a straight edge. There we go. Dang, camera didn't record the last part of the shot, so let's try it again. So my paper is not in the exact same place it was a minute ago. We are trying to find this angle using the compass bearing. And so to do that, we kind of have to turn it around so that we're dealing with north. So we have to pretend we're facing north perfectly straight up and down. And then we measure from off that north. So we're actually turning it so that it's, we'll say the south is up for our north. And we're going to take the protractor, and you may need to extend your lines out so you can see everything. So I'm going to line it up. There he goes, right there on my perfect line. North, south, east, west, or up. Okay. And now I'm going to look and measure, and I'm going to look at the angle and know the angle comes out, because it's this angle that's coming here and it continues out to here. So 10, 11, 12. So I know my angle degree, that theta, is 12 right there. And if I drew the line over, I would know 78 degrees is the rest of it if I needed to know that. So then I have to look at it and go, well, how do I know what the bearing is? Well, I'm looking at it north-south reversion, and it's going up this way, it's going 12 degrees. So my bearing for this one is south 12 degrees east. And then there's the measurement. So if I'm doing 2 to 3, we do the same exact thing. You flip it around. There you go, 2 to 3. Find your north to south, east, west on that 2 to 3 right here. Bring that line up because you're going to need it. Then you line your protractor up and find what is the angle. What is the angle on your protractor? Okay? So again, and you may need it to come out more. I'm just going to assume it needs to come out more before I even try to do it. So move it back around where we have our little 90 degrees, or our north. Line it up. Angle comes out 10, 20. What? So measure it and go find 10, 20. Find that measurement on your protractor. Mark your angle. What is the degrees? And that'll give you your bearing. And then you do your math again to find the actual length.